Hey everybody, welcome back. So, what I want you to do before we get started today is just to recap what we've done so far. It's important for what we're going to move into today because we're going to be looking at some special products. So, go ahead and pause the video right now and do these two problems in your notes. The first one you're going to factor, second one you're going to multiply. Okay, hopefully you took my advice and did that. So, again, when we're going to factor these trinomials, we're looking for factors of negative 108 that add up to a positive 3. We're looking for those two binomial factors. So if I was to take negative 108, which is kind of an unusual number, we don't see it a lot, and think of all the different ways to make 108. I have a negative, so I know one of them is going to be negative. So negative 1 and 108. Obviously, that doesn't work. I've got a negative 2 and a 54. Doesn't work. Negative 3 and 36. Getting closer. Negative 4 and 27. The reason I'm making the small numbers negative, in case you're wondering, is because the b value is positive. So I know the bigger number is going to be the positive value. All right, so continuing my my product tree here. 4, 5 doesn't work, but 6 does. So negative 6 and a positive 18. Almost there. Differences are getting smaller. And then the last one ends up being what I'm looking for, negative 9 and a positive 12. So my two factors for this are going to be x minus 9 times x plus 12. Okay, so if you got that one, good job, because it is tough when it's kind of an unusual product. Negative 108 is not really one we see a whole lot. All right, and then when we multiply the second one, we're going to use FOIL. So first times first, x squared, outside times outside, 6x. Inside times inside, so another 6x. And 6 times 6, so plus 36. Combine like terms. And there's my simplified trinomial. Okay, so hopefully you're following along with what we're doing so far. This is where you should kind of be in that comfort zone, and at least nearing the comfort zone. Hopefully we've done enough problems where you're feeling a little bit better about these. If not, then I definitely recommend revisiting those IXLs. Try to get them as high as possible because that's going to give you some of the more challenging problems. Okay, so that brings us to our topic for today, which is 6.4, special binomial products and factors. So we're going to try to cover this on one lesson. So make sure you take good notes for yourselves. Nothing new here. This is just special situations. Okay, so we're going to see kind of a pattern emerge, which is going to save us time both when we multiply and when we factor. So make sure you're following along as we go. All right, so if I ask you to multiply these binomial squares, I guess that's what we'll call them, there's not any difference between these particular ones. And if I was to ask you to say, I don't know, do 3 squared, right? Anything squared is just that number or that value times itself that many times. So 3 squared would be 3 times 3. So there's no difference here when we have x plus 3 squared. All that means is we have x plus 3 times itself twice, right? So x plus 3 times x plus 3. So for this one, I could use FOIL. I'm actually going to save some time and use the shortcut, right? So I have a binomial times a binomial, so I'm going to take x squared is always going to be first, right? That's that first time. And then I have a 3x and a 3x. In other words, I have 3 plus 3. So the middle term is going to be 6x, right? This will be the result of 3x and 3x. And then my constant term is just going to be 9, right? The product of 3 and 3. So hopefully you're familiar enough or at least comfortable enough with the shortcut where you don't necessarily need to write it all out, right? And if you do, that's fine. Just realize that as we kind of move away from the long version of this, you're going to start seeing more and more of the shortcut when it's available, because it does save you some time. So we're going to have x squared plus 8x, right? Because I have 4x and 4x, and then plus 16. For this third one, I'm not even going to write the expanded portion. I'm just going to say, okay, I know it's x squared. 5 plus 5 is 10x. 5 times 5 is 25. All right, so do you see a pattern with these results? Okay, and if you don't, that's okay, because we're going to talk about it in a minute. But take a second, pause this, and just try to figure out, okay, there's definitely a pattern here. And to give you a hint before we move forward, we're looking at these two values here. And really, we're really focusing on that middle term. We already know the third term is going to be whatever this number is squared, right? So 3 squared, 4 squared, 5 squared. We already know that result. So really, we don't even care. Whoops. Really, we don't even care about this last term. We already know the pattern for that. So what I want you to do is try to focus on, all right, well, what do all three of these numbers have in common? And would that pattern hold, no matter what number we had? And the answer to that would be yes. So hopefully you recognize, hey, they're all even. Okay, so that's something to think about. They're all even. Okay, so let's look at some more what we're going to call as perfect square trinomials. Okay, the reason we call them perfect square trinomials to back them up. So if we were to factor this, and we'll come back to this when we go to factoring these, if we were to factor each of these trinomials, okay, each of them factors down to a single binomial times itself, or a single binomial squared, right? So the reason that's why we call them perfect square trinomials, because they do factor down to that. So let's go ahead and take a look at these. So this is just going to go off the same thing we were just doing. So I'm just going to use the shortcut. So x squared, 6 plus 6 is 12, so 12x, and then 6 times 6 is 36. That's how fast the shortcut can be. All right, so now we have a unique situation here. So I have a coefficient, all right? So I might not want to use that shortcut. Maybe let's try it first the expanded way and use FOIL. Okay, let's see what happens. So I've got the first times the first, so 4x squared. The outside terms, so 2x times 2 is just going to be 4x. Then I'm going to get the same result from the inside, right? So that kind of holds true. That's still the same, so 4x again. And also, with those last terms, it's still going to be 4. So combining like terms, I end up with 4x squared plus 8x plus 4. So really, the only thing that changed was the fact that I had this coefficient in front. And if you compare that to, I don't want to use orange, compare that to, okay, well, how did that change the number in front, that lead coefficient, and how did it change that middle term, right? So think about, okay, well, we actually end up multiplying these. So 2 times 2 would be 4, and then we had two of them, right? We had a 4x and a 4x. So you can kind of create your own shortcut from there if you want. But let's go ahead and use the expanded version for this third one as well. So 3x plus 4 times 3x plus 4. And again, if you're not comfortable with a shortcut, that's totally fine. Just realize that FOIL is your buddy, right? So we can just do first times first, 9x squared, outside times outside, plus 12x. Inside times the inside, another plus 12x. And last times last, so plus 16. So in this case now we've got 9x squared plus 24x plus 16. So let's compare this to what I talked about on the previous slide. Notice something interesting here. Again, those middle terms are both even. hopefully you remember what it means to be even, because we're going to use that later. All right, so does the same thing work? All right, do we see the same pattern when there is a negative sign? Now, obviously, A and B are just placeholders. First time you've seen it, so, let's kind of work with it for now. So the ones prior to this would be considered like A plus B squared, right? So this one, now we have minuses. Let's see how this changes the game. All right, so we're going to do the first one expanded again. So x minus 6 times x minus 6. If you want to use the shortcut, that's totally fine. So I'm going to use first times first would be x squared. The outside terms would be negative 6x. The inside terms would be negative 6x again. And then the last term would be positive 36. Combine like terms, and I get negative 12x plus 36. So nothing really changed, but also, hopefully you notice, keep an eye on it, it's still an even number in the middle, right? That b term. Remember, we're still working with ax squared plus bx plus c, or this could be a minus minus. Let's try it with this one where we've got 2x minus 2 times 2x minus 2. Right, 2x minus 2 times itself. First times the first would give us 4x squared. Outside times the outside minus 4x. Repeat it again because the inside is the same thing, so negative 2 times 2x. And then the last terms would be plus 4. Combine like terms in the middle, we get 4x squared minus 8x plus 4. Look at that. Again, even number. Right? So no matter what number we pick, or no matter what number our binomials are, we still end up with that middle term being even. That's going to be important in a minute here. All right, let's do this last one, and hopefully we can start to draw some conclusions from this. First times first would be 9x squared. Outside times outside times outside minus 12x. Inside times the inside, right? Or right here, negative 12x. And then last times last plus 16. Combine like terms once again. And what do you know? It's an even number in the middle. Okay, so if you can't see the pattern, let's kind of break it down. All right, so I'm going to kind of swipe through some of the ones we just did and point some things out. All right, so let's begin beginning. Notice that the first term is still x squared, right? Even if I go to the next slide here, I had x, well, now I have x squared. I had 2x, right? 2x times 2x. I still end up with that term squared. 3x, obviously, 9x squared. Here, x gives me x squared. Hopefully you get the idea. 2x squared, 4x squared, 2x, 4x squared, 3x, 9x squared, right? So definitely a pattern there. Definitely a pattern there. Let's go back to the very first one again, and let's look at the middle term. No, sorry. Let's look at the last term, because that's easier to spot. This one obviously is just that number squared, right? 3 squared is 9, 4 squared is 16, 5 squared is 25, and so on. 6 squared, 2 squared, 4 squared, negative 6 squared, right? The sign didn't really matter. You still end up with a positive number. Okay, so let's talk about the interesting part, and that is the middle term. So when we look at the middle term, we already know that they're even. Okay, so what does it mean to be even? Hopefully you remember it means that they're divisible by 2, right? So if I was to take this number here, positive 6, and divide it by 2, let's do red. If I divide this by 2, 6 divided by 2 is 3x, right? 2 times 3x would be 6x. This 8x, if I divided it by 2, would be 2 times 4x. This middle term, 10x, would be 2 times 5x. You start to see a pattern here when we relate it to the original binomial, hopefully. Let's look at the next one. So I've got a 12x. Let's divide it by 2. 2 times 6x. Well, look at that. I got a 6 and an x. I have an 8x. So again, we've already seen this. So 2 times 4x. But now we got something interesting. We don't have a 4 and an x. But we do have a 2 and a 2. So really what we have is 2 times 2 times 2x. Right? And if I divide 24 by 2, I get 12x. But really what I have is a 3x and a 4. And I put those out of order. Doesn't matter though. Okay, so if you were to look at that across all of them, they're all going to be the same. All right, so let's talk about this pattern and how it can work for us. Okay, so we can create a rule for these. So if we were to come up with a rule, and actually, let me go ahead. Let's back up. Let's not talk about a minus b. Let's talk about a plus b first. Okay, so a plus b squared. Now, if I was to do this expanded, right, just with generic placeholders for numbers, let's see what happens using FOIL, right? So if I take first times first, I get a squared. If I take outside times outside, I get ab, right? A times b is ab. If I multiply the insides, I get ba, which is the same thing as ab, right? Because it's multiplication. And then the last terms would be b squared. So following the same protocol we've been using for the last couple of days now, we're allowed to combine those like terms. So guess what? I have 2ab, which, if you're following closely enough, matches the pattern of everything we just saw, right? You had the first term squared. You had the last terms squared, right? Let's just throw one up here, x plus, I don't know, 5 squared. we had this number squared, so x squared. We had this number squared as a constant, so plus 25. And then we ended up having the middle number, the middle term, being divisible by 2. That's where this 2 comes from. And then a times b. So if we took this as the a value and this 5 as the b value, we could do a times b, or in this case, x5 or 5x, right? But we also have this 2 in front of it. So it's 2 times 5 times x. Put it all together, what do you get? You get 10x. Okay, so it's a neat little trick, little pattern. Important to recognize when this happens because it does make things easier when we do the reverse, which is to factor them. All right, so here's your generic rule for a plus b. Well, it's really just, this, okay? So let's write it out so you have it for your notes. Anytime you have an a plus b squared, notice what I do here. I'm going to put a double arrow because if I'm multiplying, that means I'm going to the right. If I'm factoring, that means, guess what? It factors back to a plus b squared. So a lot of people have trouble spotting this pattern. We'll talk about this more in the next lesson, but for right now, I just want to focus on the multiplication part. Okay, so it's always going to follow this pattern, a plus b squared. That's going to create a perfect square trinomial. Okay, and I think there's a slide. Well, yeah, we can use these. Nope, sorry, that's a different pattern. So let's look at a minus b because we've done enough practice problems with those, or at least examples. So again, the double arrow because you can multiply to the right or you can factor back to the left. So here's what's nice about this. I know formulas can be confusing, but the only difference here, if you have a minus, that means you're going to have a minus here. So now it's negative 2ab plus b squared. Okay, so both of these are perfect square trinomials. All right, and I know this is a long one, but there is one more pattern that we need to work with. And this is called the difference of squares. Okay, so if you look at these three, I want you to first recognize that there is a pattern to these. Right? Hopefully you notice there is a positive and a negative of the same binomial. Right? So pause this for a second. Do FOIL on this, and let's see if you get it right. All right, so if we FOIL these out, we get first times first, x squared. We get outside times outside, minus 2x. Inside times inside, plus 2x. And last times last is negative 4. Now, what happens in the middle when we add like terms? Well, those cancel each other out, right? Negative 2x, positive 2x gives you 0. So we're left with this x squared minus 4. This is what's known as the difference of squares. Hopefully you recognize the fact that it is in fact a difference, right? Because it's a minus. And it's of squares because they're both square terms. Comes in handy later when we factor, trust me. So let's look at another example. So if I do first times first, I get 9x squared. Outside times outside, negative 18x. Inside times inside, positive 18x. And last times last, negative 36. Now, hopefully, you're spotting the pattern. Okay? If you can spot the pattern, you recognize that those middle terms are going to go away. So really, the only thing you care about is this thing times itself, right? 2x times 2x is 4x squared. And the second term times itself, 25. And we know that it's going to be a difference, right? Because one's positive, one's negative. So this is going to be 4x squared minus 25. It saves you a little bit of time. Okay, so I'm going to stop there. And what I want you to do is work on the assignment. We'll talk about factoring these in the next one because I don't want to make this too long. But go ahead and stop at that point.